Okay, so what we have here is the Rubidium Dichromate that I made before, back in November. Now, what I've done is I've dissolved it in about 1 liter of water because as I was rechecking the literature right before I went to go and start doing this, I came across something that somehow I had missed before, and that is that barium potassium chromates and barium ammonium chromates are a thing and can precipitate out of concentrated solutions. Obviously, this could be a little bit of a problem. Now, if we hit the endpoint perfectly, there should be very little barium ion left in solution. Now, these complexes form with chromate in concentrated solutions, so I'm really hoping that if we remove the barium chromate and we're very careful about hitting the endpoint and we keep everything nice and dilute, that this should go without too many problems. And what I was also thinking about is that, okay, barium hydroxide is slightly soluble in water. Not so much so in cold water, but it's still a decent amount will dissolve. However, barium carbonate is wildly insoluble. So perhaps we could add ammonium carbonate to the solution after we hit the endpoint to try to precipitate out any barium ion that might be there before we start concentrating it. We'll see how it goes as I go along, but I'm thinking that might be our best bet here. So I'll come back when I've got this measured out and we are ready to go ahead and actually start this. Alright, so since I've never done this before, I've decided, after giving it a lot of thought, to break this into a smaller portion and try it with that and see what we get. That way, if it works, fantastic, we know it works, and if it doesn't work, well, I haven't just lost all of my rubidium dichromate. So, the temperature out here is about 19 degrees C. This stuff is supposed to be soluble to an extent of about 5% per at 18C. So, in theory, there's somewhere around, I don't know, a few grams in there. That's theoretically. Now, if we went off the theoretical yield of this stuff from before, since I never did weigh the dry product, we would need about 28 grams of barium hydroxide octahydrate. And that means that if we were to scale that down to about 1/10, that would be about 2.8 grams. So I figure we'll start with about 1.5. And we'll dissolve that in some water, combine that with this here, and we will see what we get. And since we want to avoid the formation of that complex, the more dilute the better. So I may even dilute it past this just to give this a try for the first time. So anyway, I'm going to weigh out the barium hydroxide, get that dissolved in some water, and I will come back when I'm ready to get it on. Shit looks, man. Alright. Be nice if you would open. Ooh, it's little meth-looking flakes that instantly liquefy. Alright. Well, that's a good sign. That was actually 2.25 grams. A little bit more than I would have liked, but I'll just add a little bit more water here. Alright. Don't want to go overboard on the water, though. So I'm going to have to boil it all off, and it's going to take for fucking ever. Alright. Let's put this bitch on the heat and let it warm up for a little bit. Alright everyone, I've diluted this down to around 300 mils. It's warm, but it's not super hot yet. All of the barium hydroxide has just dissolved. So, I'm going to go ahead and add our solution to this. Here goes nothing, people. Okay, it's in excess, but that's fine. I'm going to give it a little swirl here. And I'm going to put it here. I'm going to cover this up. Let the barium chromate settle out, which shouldn't take too long. And then, I'm going to go ahead and filter it off. And then I will react the filtrate with some more barium hydroxide. And this time I'm going to do it much more carefully in smaller portions because, again, I want to try to get something close to the end point. I don't want to overshoot it by too much. I really think that we can add ammonium carbonate afterwards, and that will help remove any excess barium. But again, I just don't want to go too far, because while we can remove ammonium carbonate and ammonium hydroxide, it's just better to keep any kind of stuff we have to do to this to a bare minimum, because there's no way for me to completely exclude sodium no matter how much I clean my glassware. No matter how careful I am, it's still going to get in here, and I'd really like to try to keep it to a minimum, and especially potassium, because while sodium doesn't really form a lot of complex salts, I mean it does, they tend to be more soluble, and the rubidium and cesium ones are the ones that are far more interesting. Alright, so yeah, gonna cover this up, gonna let it settle, and then we're going to separate those and move on to the next step. Okay, everybody, it has taken several additions of barium hydroxide to get this to this point, but I have finally precipitated out all of the dichromate as barium chromate. We're getting a nice, clear solution here, finally. Isn't it beautiful? So all I'm going to do now is filter this down. No worry about it being concentrated. It is ridiculously dilute. What I'm going to do is, after this is all filtered, the plan will be to combine it with some ammonium carbonate, precipitate out any barium that might be in solution as the carbonate, filter that off, and then start boiling this down. Again, any excess ammonium carbonate or ammonium hydroxide that might form will just be driven off when we boil this stuff as ammonia and water, so no problem. Anyway, I will come back when I've made more progress on this and I've got something else to show you guys. Okay, so it's the morning of the next day. I finally got all of the solution filtered. You can see the ridiculous volume that this got diluted to as I continually filtered this and kept reacting it with solutions of barium hydroxide, barium chromate would precipitate. I'd filter it, did this over and over again, until finally all of the chromate has been removed from solution, so far as I can tell. All of the evil yellow chem has been dispelled. Anyway, I think something interesting happened last night, though. In this flask, which wasn't covered up, there is a very small amount of a fine white precipitate in the mixture, whereas in the mixture that was covered up, it's not there. Well, there's a teeny tiny amount. The only thing I could think that could be is either barium hydroxide that precipitated out of solution, or it's possibly barium carbonate. because barium hydroxide will react with CO2 to form carbonate. I know that can be a problem when you're working with barium hydroxide in some procedures. A lot of them will call for freshly precipitated barium hydroxide. But I don't actually know how quick that reaction is, just how readily it actually happens, so I'm not really sure. So what we're going to do now is we are going to go ahead and add some ammonium carbonate to this, and hopefully that will drop out any barium in solution as the carbonate, and theoretically it should convert the hydroxide into the carbonate as well. So let's give that a shot and let's see what we get. Okay, might help if the power was on. And I'm using such a little stir bar because all of my other ones are tied up in other projects that I have going on. Oh, wow. Okay. Nice. Nice. This is encouraging. Very encouraging. Ha! Fantastic. It worked. It fucking worked. At least I'm presuming it worked. No idea how much of this I have to actually add. But at least I can add a solid, and it doesn't increase the volume. Tell you what, we'll just go with that there. Let it stir for a little bit. I will filter it, and then I will come back once I am done with that. Oh, that's so cool. I just wanted to show you the filtration process real quick. Very insoluble salts like barium carbonate typically precipitate out as very fine particles. The reason that I'm not vacuum filtering this is because the Fritig glass filters often don't catch the smallest particles. What I'm using in order to get a nice clear filtrate off of this is a plug of cotton, like this. It comes out of a pill bottle. The only pill bottles I've seen that have these are the generic Imodium from Family Dollar. Seriously, I've never been able to find any others. Usually there's some kind of synthetic fiber, but when you buy super cheap stuff from the super cheap dollar store, you get actual cotton. So these things are great. I just stuff these down into the neck of the funnel, and then I'll use a couple of regular old coffee filters here. Usually I'll double them up. I'll use 2 of them. And yeah, that always catches even the finest particles. I mean, you've got to be patient and wait on it. But, I mean, you won't have to filter it multiple times. So, anyway, just thought I would share that little trick with you. Okay, everybody, the moment of truth. This is the acid test, as it were. This is a little bit of ammonium carbonate that's dissolved in water. I'm going to take the funnel here, which has our filtered solution dripping through it. And no precipitate. Yes. Awesome. That means that we got rid of all of the barium, or at least down to the limits of the solubility of barium carbonate, which is pretty damn low. So, I mean, there's essentially it's down to trace levels, or close to that. So, yay! We have done it! We have fucking done it! The only thing that remains to do now is to finish filtering this, boil it down, which is going to take a while, and then I guess react it with an acid or something else that will conclusively prove that we've got rubidium in there. I'll have to come up with something. Alright everyone, so this is what I've decided to do. I'm going to go ahead and end the video here since it is getting a little long. Also, it's probably going to take me the entire day to boil down that solution in order to get something that is approaching concentrated. I'm still trying to come up with a couple of good ways to conclusively prove there is rubidium hydroxide in that solution. I mean, I thought of, just reacting it with an acid, letting it crystallize out. I mean, if we got some cubic crystals, and a lot of them, that would definitely speak to the presence of rubidium. But I prefer something that's a bit more specific. Something that, will drop out of precipitate with rubidium that's not going to do it with sodium. Also, I'm going to have to make sure that all of the ammonium ion is removed before I do whatever test it is I'm going to do. And I'm really hoping that just boiling this down to a concentrated solution is indeed going to just take care of that problem. Ammonium carbonate, I mean, is used in baking because it breaks down at high temperatures. So push comes to shove, all we should have to do is heat up, the material we get from this to a high temperature for a short time in order to remove any ammonium carbonate that may be lingering. But hopefully, with it boiling down like this, that will get rid of it all. But if you've got any ideas for tests that I can do, I would love to hear them in the comments. Please let me know. And stay tuned because I will be putting out another video, a follow-up one in the very near future where, I do some tests on this in order to conclusively prove that the rubidium is there. But anybody that's got ideas, hey man, the more information we can get out of this, the more tests we can run, the better. So please let me know. And with that, I'm just going to give you the usual little closeout spiel here. If you liked what you saw, give it a thumbs up. If you didn't like it, give it a thumbs down. Subscribe if you think I've earned it. Share the video. And of course, please comment with your ideas on what I can do to test this solution. And I will see y'all in the very near future.